in this problem, I've got carbon dioxide in a piston cylinder, and it's compressed from this state to pressure of 11 bar. It's got an initial volume given. The process is polytropic, where N is 1.25. It's an ideal gas, neglect kinetic potential energy. It wants me to find the work and the heat transfer for the process. Okay, so the first thing I'm going to do is find the work of the process. Now, again, knowing this is a polytropic process, I can find that the work is P2V2 minus P1V1 all over 1 minus N. Okay, where N is 1.25. I know P1, I know P2, I know V1. Basically, the first thing I need to do is find V2. That's the only thing I don't know in this equation. Okay. Now, because it's a polytropic process, I know V2 over V1 to the N power is equal to P1 over P2, right? And again, I know P1 and P2, and I know V1. So, and I know N is 1.5. So from this equation, I can plug in the numbers and I can calculate V2, and I find that V2 is 0.02892 cubic meters. Now knowing this volume and all of this stuff, I can plug in, I'll go ahead and plug these values in. That'll be 11 times 10 to the 5th times P2, or I'm sorry, V2 is 0.02892 minus P1, which is 0.7 times 10 to the 5th, times V1, which is 0.262, divided by 1 minus 1.25. So again, I know everything in this equation. The units will work out because I've got newtons per meter squared times meters cubed. So that's going to give me Newton meters, which is a joule. And I ultimately get negative 53.89 kilojoules. So that is the work of the process. Okay. Now, in order to find the heat transfer of the process, I'm going to use my first law equation, which of course is delta U equals Q minus W. So I'm looking for delta U here. Okay. So this is carbon dioxide. It's an ideal gas. I need to know the temperatures in order to look up the U values. Okay, so let me go ahead and find T2 here so that I can look up that value as well. Okay, now again, this is an ideal, the polytropic of an ideal gas, and I can easily find the relationship between, again, T2 over T1, and I can do that related to my pressures equals P2 over P1 to the N minus 1 over N. And again, this is because it's a polytropic process of an ideal gas. Again, I know my pressures. I know T1. I know N is 1.5, so I can easily calculate then that T2 equals 485.7 Kelvin. Okay, so now from this and T1 of 280, I use table A23 for carbon dioxide, which is this guy right here, and I can look up U bar. So at 280, you can see U bar is 6369 kilojoules per kilomole. And at 485, I'll let you do the calculations yours, but it's going to be in between 12.8 and 13.1, which more or less 13 is 13,004 kilojoules per kilomole. Now this is given to me in molar form, which I don't like. Okay, so let me go ahead and say, okay, U1 equals 6369. Look that up in the table. That means U1 is 6369 divided by the molar weight for carbon dioxide, which is 44.01. Again, that's found in table A1. Okay. U2 is going to be, again, 13,004, and that's kilojoules per kilomole divided by 44.01. So this is U1 and this is U2. Okay. Now coming back here, this is uppercase U. So again, what I'm looking for is the mass times U2 minus U1 equals Q minus W. So I also need the mass in order to get this first law equation to work out. Okay? Well, from the ideal gas model, my mass equals, well, again, it's PV equals MRT, and that would be RT divided by P, and this would be the big V. Okay? Where R, again, in metric is 8314 divided by the molecular weight, or the molar weight, whatever you call it, 44.01 for carbon dioxide. And I will do the first one because I have all of those given in the problem. So temperature is 280. Pressure is 0.7 bar, so that's 0.7 times 10 to the 5th. Volume is 0.262, which gives me a mass of 0.3467 kilograms. Which means from this equation I can rewrite things and say, okay, well then Q equals 0.34667 times U2 minus U1, which is going to be 13,004 divided by 44.01 minus 6369 divided by 44.01 plus, well, it would be plus a negative 53.89, which gives me a Q equal to negative 1.62 kilojoules. Okay. So again, using what I know about polytropic relationship, I can find the work, I can find the relationship between the volume, pressure, and temperature, then using the first law, knowing the work, and then the tables that I look up U for temperature. Again, the U in the tables are U bars, so I need to divide that by the molecular weight to get the U in mass terms. Once I get that, though, I can calculate Q from the first law equation given here.